Hello and welcome to this GCSE Science revision video for core physics on energy. In this video we will cover types of energy, calculating efficiency, electrical power and the cost of electricity. There are many different types of energy. These types include magnetic, kinetic or movement energy, heat or thermal energy, light, gravitational potential energy, chemical energy, sound, electrical energy, elastic potential energy, and nuclear energy. Energy transfer diagrams can be used to show how energy is transferred in some sort of mechanism from one type to another. Different types of energy can be transferred from one type to another in different mechanisms, as energy is never lost, it is only turned from one type to another. This energy transfer diagram shows the useful energy transferred in a car engine. You can see that the car engine transfers chemical energy, which is stored in fuel, into kinetic energy, which moves the wheels of the engine. This diagram below shows the energy transferred from the useful energy in an electric lamp. You can see that an electric lamp transfers or converts electrical energy into light energy. Sankey diagrams summarise all the energy transfers taking place in a process. The thicker the line or the arrow, the greater the amount of energy involved. This Sankey diagram for an electric lamp shows that most of the electrical energy is transferred to heat rather than light. Energy can be transferred usually, stored or displayed. It cannot be created or destroyed. Notice that 100 joules of electrical energy is supplied to the lamp. Of this, 10 joules is transferred to the surroundings as light. The other 90 is transferred to the surroundings as heat. The energy transferred to light energy is the useful transfer. The rest is the wasted energy. The efficiency of a device is the proportion of the energy that is transferred in useful ways. You should be able to calculate the efficiency of a device as a decimal or as a percentage. The equation to do this is efficiency is equal to the useful energy, in this case light, divided by the total energy in this case electrical energy. And to turn it into a percentage, we times it by 100. So in this example, the useful energy is 10 joules, the energy going in is 100, so 10 divided by 100 is 0.1. To turn that into a percentage, we'll times it by 100, so the efficiency would be 10%. The higher the percentage, the more efficient a device is. Power is a measurement of how quickly energy is transferred. The unit of power is the watt. You can work out power using the following equation. So power is equal to energy transformed in joules divided by the time taken in seconds. It's important to remember that if a watt is referred to as a kilowatt, that simply means 1000 watts. If a time is given in minutes, there are 60 seconds per minute. The more energy is transferred in a certain time, the greater the power. A 100-watt light bulb transfers more electrical energy each second than a 60-watt light bulb. The equation to the side shows the relationship between power, potential difference and voltage. So power in watts is equal to current in amps times by the potential difference in volts. The amount of electrical energy transferred to an appliance depends on its power and the length of time it is switched on for. The amount of mains electrical energy transferred is measured in kilowatt hours. One unit is referred to as 1 kilowatt hour. The equation to work this out is kilowatt hours equals power times time. In this case, the time is given in hours. Remember that in a day there are 24 hours. Electrical meters measure the number of units of electricity used in a home or other building. The more units used, the greater the cost. The cost of the electricity used is calculated using the following equation. So cost is equal to power in kilowatt hours times the time in hours times by the cost per kilowatt hours in pence. So remember, when revising, start earlier than later, keep asking yourself questions. Flashcards are an excellent way of revising, and quality of revision is better than quantity of revision. Thank you for watching this video, and I hope you do well in your exams.